Okay, great. Thank you everybody for making it past the break, sticking it around for my talk today. Thomas gave me a nice introduction, but my name is Adam Terlson. I actually want to start this talk by saying we would love to have you talk here at React Munich, yeah? So if anybody's interested in talking, it doesn't need to be anything super awesome, super professional. We would love to have you talk here. So my talk today is building mobile first with Redux Saga. And I want to talk about where I work because it's relevant to what I'm about to talk about. So I work for a company called Internations. We're the world's largest social network for expats with over 3 million members. And we're building a new app in React Native. And we, of course, use Redux Saga. How could we not? And of course, we're hiring, so if you want to join me and my awesome team of colleagues to build this app, hit us up. So I'm building a mobile app right now, but my background is actually on the web. So prior to this mobile application, I had actually never built a mobile app before. So my background, ASP, ASP.NET, .NET MVC, and also Node and single page apps. But, whoa, no. All right, we're using the keys. But in comparison to all of this, making mobile apps is much harder. And it's worth spending a little bit of time to think about why that actually is. So if you think about where the meat of your application actually lives, well, back when I started on ASP.NET, of course, we have the back end taking care of our data, our business logic, our presentation behavior, and then the front end was only concerned with display, right? This is, everybody knows this picture. Then we evolved, right? Now we're talking .NET MVC, a typical, REST architecture here. You can see REST in the middle. And here the backend is responsible for the data, the business logic, but you start to shift, yeah? Things are shifting towards the front end, adding presentation logic in addition to the display. But when you start talking about mobile apps, and especially offline first or mobile first mobile apps, the picture gets even more intense for the front end of your application. Data, business logic, presentation, display, you really have a fully fledged application in one spot, right? So the background of building apps with JavaScript is that you're predominantly interested in just building the front-end interface, but when it comes to actually building mobile first with JavaScript, the responsibility changes, and you have to build an entire application, a full application, just on one side of the network rather than spanning it over the REST interface. Mobile apps also have a lot of side effects. So what am I talking about with side effects? State management, taking pictures with the camera, different notification types, permissions, native APIs like geolocations, hardware buttons, the Android back button. And when you're building a mobile app that makes use of these side effects, the complexity gets quickly out of control. So consider one possible requirement. You want to say, when the user swipes, we're going to check for a draft version in our local state for whatever this user is swiping on. Maybe they swipe to go back, I'm sorry. And we want to ask the user if they want to save this draft before going back. And if they said yes, then we want to persist it to the back end. And maybe this request might fail and we need to do something in case the device is offline and that save was not possible at that time. But if it's saved, then we're going to show a success message, and then we're going to finally allow the user to navigate back. Right? So when you talk about building an application that has to deal with so-called side effects, you're never just talking about one, right? You're talking about You're talking about workflows which involve many different types of side effects. So this is, the most basic feature that you can imagine, but we're already involving gestures, state management, lightboxes, APIs, toast, and navigation, just for one feature, right? And now let's say the business requirements change, and you no longer want to execute this entire workflow only on swipe, but you want to execute it when the user taps on something, or maybe when some other event happens in your application. So this picture, this kind of starts to give us a picture of how complexity in our application grows non-linearly with the number of side effects that we have to deal with. So what do I mean by that? Well, let's imagine that this is the entirety of our application. We only have one side effect that we're interested in. And in the upper left, we're going to count the edges. Yeah? So if this is a node, we're going to count the edges. So if we only have one side effect, the world is pretty easy. Yeah? Maybe we're only talking with our backend APIs, right? So using something like Redux Thunk or whatever, I mean, it's perfectly fine, right? But the picture starts to change when you start adding more nodes, when you start having to deal with more and more side effects. So maybe you only have two side effects, right? So now we want to persist that API request into state, say, for example. All right, no big deal. We only have one edge in this picture. Now we add another node. Okay, things are still okay. But then we add another, we're up to 6, and another, we're up to 10, right? That is, the complexity of our application as we deal with more and more side effects grows non-linearly. Any similarity in this picture to GraphQL's logo is purely accidental. But you can tell that this is a terrible place to be in. When you have so many side effects to deal with in a mobile application, the complexity is very, very high. So what do we do about this? Well, this is where we need architecture. Excellent. Architecture will solve all of our problems. Given that everybody's here, there's one architecture that no doubt everybody immediately thought of, and that is the reactive architecture. So when you look at the reactive manifesto, it says that your application must be responsive, resilient, elastic, and message-driven. So when we're building applications with React, we tend to just focus on that first point, right? We want that responsive UI. But today, I actually want to zoom in and talk a little bit more about that last point, message-driven. So message-driven applications are nothing new, right? Myself, I've worked with any number of message-driven applications, and they're implemented across every different programming language, every different infrastructure. And this is because message-driven architectures are incredibly good at isolating different parts of your application, making it really testable, debuggable, traceable. And so message-driven architectures are a good choice when dealing with high complexity in your applications, because you can really split it apart. So no doubt everybody knows really what I'm talking about here, that is Redux. But when people think about Redux, they tend to just think about state. But it's really not about state when you choose Redux. You're choosing a side effect model, right? A way of representing effects in your system, and updating state is only one type, right? That is one node in the whole sphere of possible side effects. So I think the most important decision is not whether we're going to build our mobile applications using React. It's actually whether we're going to use Redux, right? Because React is just the presentation, right? But the real challenge of building a mobile application is everything else. And that everything else is substantially larger, substantially more challenging than just putting things on the screen, So at this point, you're probably thinking, well, what is this guy really talking about? How does this apply to me? Who cares? Because GraphQL, right? And I have to say, GraphQL is awesome, right? If you're working in an environment where you can freely put GraphQL into production, when you can migrate any existing REST APIs to GraphQL without any sort of confrontation or difficulty, or you have all the tools available to you, good for you. Like, go for it. That's not my experience, and I think that's not the experience of many people. And I also have to say that Redux, like it or hate it, is really here to stay. So this is the number of downloads on NPM of Redux versus MobX and Apollo Client. Redux has always been the winner and will be the winner in downloads for many years to come, I have to say. So that just means that it's never too late to learn Redux, right? So even if you would love to use GraphQL, I would love to use GraphQL, the odds of working on a large Redux application, if you're not already, are very high. So it's never too late to learn. Okay, you say, well, who cares? Because hooks, right? Hooks will solve all of our problems. We don't even need Redux anymore, right? Hooks are making Redux a thing of the past. Well, to this I just have to say that your application state is different from your component state, right? So using Redux for your component state may become less and less of something that you want to do all the time. And it definitely makes it easier to choose something else. But again, if the complexity of your application grows substantially, you still need to solve all of those problems. You still need to handle all of those side effects in some way. And hooks don't do that, right? So you need a solution there. So at this point, you've completely accepted my argument. You've said, you're right, Adam, I have to learn Redux Saga now. I'm completely powerless to do anything else. Excellent. So with that, I give you a reintroduction to Redux Saga. So this is kind of my mental picture of it, if you will. So I hope to introduce it in a slightly different way. In fact, you won't even see the little star character until the very end of this presentation. So when I first started investigating Redux Saga, of course you try and just figure out, well, what the hell does Saga actually mean, right? Everybody does this. And when you go onto the reduxsaga.org website, they have this nice background on the Saga concept. Yeah, work in progress. So it's really not important. Just forget the weird words, forget the weird terminology. It just gets in the way. So a saga is simply a long-running function that completely describes a side effect, right? So your goal is to just focus on simply that, yeah. And we'll walk through building this definition in a second. So when you want to build something practically with Redux Saga, you actually don't need to understand generator functions. I've attended many Saga talks. People they just immediately dive into the weeds, talking about weird syntax stuff, talking about generators, and oh, you have to know that. No, you don't, right? You only need a couple simple patterns and the simple understanding of a few helpers. So what are they? What are those patterns? Well, the first pattern is the watcher. And the watcher is a simple description of all of the work that is going to be done in your application when a side effect occurs. This is really like the core concept of Redux Saga. So what does it look like? Well, you have a long-running function which describes a side effect. And this is it, this is the core of Redux Saga. So this yield function, every time you see, or this yield keyword, every time you see yield, the code becomes it's a tool to make the code become synchronous, right? So it's a bit just like await, right? So if you see yield, think await, and everything will be okay. So take is going to wait for a specific action to be dispatched to Redux with the given type, and when it sees that action, it's going to continue into the describe block there. So when you start writing watchers, you might end up writing something like this. So this bit of code here is waiting for the device to go offline. It's going to try and reestablish a connection with the help of that forked method there. And then with the use of the Reyes helper, it'll actually cancel that if the device comes back online when the online action is dispatched. So you have this threading model, right? So you can like fork tasks and then cancel them when different actions occur. But the code remains synchronous in its flow and super easy to read, right? We're going to wait for the device to go offline. We're going to try and reestablish a connection. If the device comes back online, we're going to put a toast. Yeah? Super easy to read. So the watcher is mentally a separate thread in your application, but it's really just like any old script. And I would encourage you to not prematurely separate this script when you're first learning Redux Sagas. So I have to say, like in our code base, we probably have, I don't know, thousands and thousands of lines of Saga code. I think we use take every maybe twice, maybe 3 times, because these helpers, they do certain things that you don't necessarily need. You only need a couple simple primitives. So really try and expand these functions as long as possible, because they're really just like, not just an application script, but a movie script of everything that's going to happen when this action gets dispatched. And it pays to keep them pure. So what do I mean by that? Well, imagine you're implementing this checkout flow, right? So we're going to wait for the action called checkout to get dispatched. Then we're going to call it into our Apple Store with the payment data, and then when that's all done and successful, then we're going to display success. Okay, great. Well, not so great. That receipt might be invalid, right? So when it's dispatched, we're going to validate it first. If it's not valid, then we're going to dispatch a receipt invalid, and then we're going to show a failure message before going on to make the payment. Sorry, quick check-in. Am I going too fast through this code? Do people kind of, are you able to follow along without too much trouble? Please raise your hand if you want me to kind of slow things down and spend more time on the code. No? Okay. Okay, things are looking okay. We're not panicking yet. Okay, well, the validation function, that can actually throw an exception. So we have to add a try catch there. So now we can either show the toast for failure when the receipt is invalid, or if it throws an exception. So you kind of have to mentally jump around, and then the Apple Store payments, well, that might throw. So okay, let's just wrap that to be safe. Don't know what that's going to do. And then, oh my goodness, so now when an exception is thrown on the payments, we want to do like a backup, like saving throw, so maybe we're gonna recover from this, but that might throw, so things really can get out of control. So when I say go long, I do mean that, but you have to be careful about this. And this is what I like to call the sideways mountain. Yeah, so anybody who knows me knows that I'm a lover of mountains, but this is one mountain that I can't stand. And so the second pattern in Redux Saga that you should know is the transaction. And the transaction is simply a chunk of dangerous work. It doesn't use the while true. It's simply a utility function. And when you implement this handy transaction return type, you can see that we're making a guarantee to our watcher that the transaction is going to completely encapsulate any side effects. So our watcher can remain pure and doesn't have to worry about that. So with that simple change, that our validation and our call to the store now return transactions, the code is much, much easier. So I recommend if your watchers are getting too long, add the transaction. So now with this, you've perhaps noticed that I've never even used a function keyword here. So I've modeled this application really as a standalone script that you would just conceptually point Node at directly, for example. But in Redux Saga, that's not actually true. There's a bit of work that needs to get done to actually sort of execute your application. And the thing that does that is called the forker, or that I call the forker. I'm just making these words up. The forker controls when the watcher watches. Simple as that. It's arranging work. It's arranging context. It's the plumber. Yeah. So this is not the core of your business logic. This is not what it means to check out with a product. This is simply arranging when checking out with a product is available, for example. So when you start out writing Redux Saga, you'll just end up with a big long list of forks, right? So you're just going to fork all of your watchers. All of the effects are in effect at all times. But that isn't always true. So here's an example of a forker where I'm essentially making a channel, which is like an input stream of requests. Then I'm going to select for any existing requests that have been saved into state, and I'm immediately going to loop through all of them, and I'm going to shove them into the channel. Then I'm going to fork my watcher at the end, and that thing will begin consuming the requests out of the buffer, right? So this is incredibly handy when it comes to building mobile applications offline first, right? So what happens when the user wants to take an action, but it's not available because the device is offline? Well, you could either throw an error, or you could actually buffer those requests, wait for the device to come back online later, and then service them, right? So it's an incredibly powerful tool to buffer work when the situation isn't right. So actually, by way of example, we use React Native navigation by Wix. And anybody here building with React Native? Okay, a couple of you. You know how awesome navigation in React Native is. I mean, that's the best part. So we found a bug in React Native navigation where if you tried to display a toast message too quickly, they would just like jank out, and then like the animations would get stuck, and it was totally broken. Well, the fix was simple, right? We had one watcher looking for those actions and displaying the toast message. So simply add a channel there to buffer any of those incoming messages and throttle the rate at which that buffer is consumed. Super simple. So when these forkers grow perhaps even more, they might start to look like this. So here we have two channels getting created. So again, the channel is just a buffer. So one here is conceptually for push notifications, while the other one is for connectivity status. Then we're going to go on in our code, enter into the while true loop. Then we're gonna race. So we're gonna do all of these things now simultaneously. We're gonna watch push, watch connectivity, and watch user input. But now, think about what this code will do next. So the watcher has a while true at the top. And so conceptually, it should actually never complete. So none of these functions should ever complete And the race should never continue on. But the exception to that is an uncaught error, right? So we can actually wrap the entirety of our Redux Saga application in a try-catch block. So the reality is that doing this at the top level of Saga can prevent your application from crashing. So anytime you make any sort of like weird syntax error or, I don't know, just something breaks unexpectedly, you can actually contain all of those exceptions. So in this case, an exception gets thrown unexpectedly. We would then log that to our backend to investigate. And then what happens? It actually goes up to the while true again, right? It then reforks all of our watchers so we can continue processing requests, right? So you can even build some sort of high availability system, if you will, in Redux Saga. So in summary of everything that I've shown you today, if you want to start building a mobile application in Saga, you only need these 3 simple patterns, and you only need a couple helper functions. And it didn't take an understanding of generators. I didn't even go through and explain exactly what every detail of the different helpers are. You can just discover that as you go. They read very intuitively. The watchers are super descriptive, super easy to debug, and it's a very powerful tool. So, with that, let's try writing some together live. What could go wrong? All right, so we're gonna play a game together, and this game is a typical RPG. Yeah, so this is like mages and orcs sort of RPG here. So we're gonna have a hero. We're going to have a monster, and they're going to enter a battle to the death. All right? So when you start building with Redux Saga, I encourage you to just focus on the side effects, right? So Redux Saga is a tool for side effects. So when you think about in RPG, what are the side effects in that world? Well, let's focus in a little bit more. Our hero. What are the side effects for our hero? Well, I've actually kind of articulated some of them at the bottom, so I've protected myself in this demo with a whole bunch of tests. So hopefully, once all the test passes, I cannot fail. So that you may see down at the bottom here that one of the, maybe I can make that a little bit smaller. Is that okay? Yeah. So one of the side effects that our hero can do is attack the monster, right? So what do we need to do to start? Well, we just write our watcher. So we're going to watch, it's called a tick, and we're going to start with our while true. All right? So, okay, a bit of plumbing for the game. In order to make sure that all of the players in this game are sequenced, the game will actually dispatch a tick. And this is just a mechanism by which the game keeps track of time, right? So a tick is just really a turn for each player, right? So our hero is going to wait for its turn. So game tick. So it's going to wait for its turn. And now here is where I'm going to describe the entirety of what this player will do on its turn. Everything goes right here. This is just a rather simple example. So in this case, it's going to attack, right? But maybe, well, here, I can do that. So yield put, it's going to damage the monster, yeah? So if I save this, oh, yeah, let's give it a valid action. If I save this, I get a bunch of battle tests. Okay, it attacks. All right, but maybe our hero is a mage, maybe, and it's got some sort of spell casting time, right? So really what this thing needs to do is it needs to wait for another turn. because it takes 2 turns in order to attack. Okay, great. But what if our mage gets hit while spellcasting? Well, obviously it's going to get interrupted, right? So with that, we need Reyes. So here we're going to just get rid of those lines, and we're going to say whichever of these wins first is the result, right? So if another if another turn comes around, well, then our spellcast is successful. Sorry, should learn to write code. But if we take damage, hero damage, then our attack is going to get interrupted. And we can tell which one of those won by the return value here. So I'll just say cast completed, or complete. And then this only gets dispatched if cast is complete. All right, how am I doing? Text monster interrupts the attack. Great. I think we can turn off the verbose mode. Maybe that'll make life better. Or not. It's just weird formatting. Okay. All right, next. What else can our hero do? Well, so our hero can attack, but our hero could also take damage. Okay, so that's another side effect for our hero. Watch hero damage. Great, while true. This happens all the time, and here we're going to take on the hero damage. All right. So now, what happens whenever the hero gets damaged? Well, we're going to put another action, and this is hero health decrement, right? So this is actually going to land in our reducer and update our hero's state. So I can run the test. That should be another pass test. Yep, reduces health on damage. Next requirement, our hero needs to die. Okay, so we decreased our health here. So now we're going to use another helper called select. We're going to get state here, and we can say state.heroHealth. And this gives us a result of health. And then if the health is less than or equal to 0, then that's a different side effect. So we're gonna put that out, and that's hero dead. Okay. Everything clear? I'll take your blank looks as positive feedback. Okay. All right. So great. Now we've completed our hero. So we can wrap both of these things up. So this is our forker. So we're going to yield fork, watch hero tick, yield fork, watch hero damage. Great. Our hero is complete. Maybe. What is going on? Give me my pretty print. Attacks, interrupts, reduces health, dies. Great, success. Okay, next, let's think about the effects on our monster, right? So we're gonna watch the tick again, and our monster needs to take his turn. Oop. Well, true. You'll take the game tick. Great, so now it's our monster's turn. Well, our monster can also attack. But our monster attacks a little bit differently. Rather than taking 2 turns to attack, it will actually, it's more like a chaotic monster. It can attack more quickly, but sometimes it misses, right? So the monster is going to actually make a dice roll to see if its attack is successful. And we're going to call math.random here. So So our role is that. Now, why do I call math.random instead of just invoking this function directly? Well, this is because the call helper gives us some advantages, right? Remember that we're trying to write a pure function here, but random numbers are in fact not pure. So we can isolate our code by using this call helper. And the call helper has a whole bunch of other things into it. You know, you could just call a normal JavaScript function, you could call a promise returning function, you could call another generator function, and call just kind of models them all in exactly the same way. So whenever you're dealing with a function that might produce side effects, you should always use call. In fact, just always use call and you'll be fine. Okay, so if our roll is successful, so we have like a 50-50 shot of the monster attacking, then we're gonna output, or we're gonna cause a side effect on our hero by putting out hero damage. All right. See if I can. All right. So our monster's attacking the hero, misses on an unsuccessful roll, it hits on a successful roll, great. So now we have our last monster function here. So our monster also needs to take damage. So watch monster damage, while true. Here we're going to yield take on the monster damage. Then we're going to put out the monster health decrement, just like the hero health decrement above. Then we're going to select the health back out of state by using select here. State monster health. Great. Then if the health is, well, maybe our monster is actually like the undead or something. So if it's less than -1, then we're going to yield put type monster dead. Okay, so we have our monster damage. I shouldn't do that. That was ad-libbed. I mean, that might cause problems. All right, so now we need to wrap up our monster capabilities into our monster forker here. So this is just going to yield fork our watchers. Oops. All right. All right, let's check this. So we're dying, we're missing. Uh-oh, dies at 0 life. Haha. Bug. All right, good. We're running. All right, so now we have a game, and I didn't want to write this one completely on my own, but here's the implementation details of the game. We have an optional logger here, which I can show you, which will just output every single action which is dispatched into the system. But so here's the definition of our game. Yeah, we're going to put the hero into the world. We're going to put the monster into the world, and we're going to wait until one of them is dead. It's a super awesome description of our game. So I hope in this you can see the awesome expressiveness of Redux Saga. You know, we take a highly asynchronous sort of thing, like playing a game, and we just so tersely, so succinctly describe everything that is happening in that game, right? And so really every application that you build is simply just a game. And I hope you can see how easy it is to do. So just for completeness, if you're curious, this is what the reducer looks like. Yeah, and so if we run this game, we should have about a 50-50 shot for whether our hero wins, right? So the hero takes a second turn to complete its attack, but the monster has a 50-50 shot of missing. So you would expect a 50-50 chance of our hero winning. So what do we see? Winner false, okay. Winner true. Winner true again. Looks like 50-50 to me. In fact, it was perfect. That worked out incredibly well. Yeah. Great. So our game works. All right. How am I doing on time? Okay. So maybe this is a pick your own adventure game. I can either wrap things up or I can show you how these tests work. Tests?
Yes.
Tests. Everybody loves tests. So testing in Redux Saga is interesting. So if you go and read on the Redux Saga website, they say, oh yeah, it's super easy to test. And that can be true, but the tests are fundamentally flawed. And that's because they use this generator syntax, and you're asserting on what is yielded from your generator, and then you have to inject what comes next. Well, sometimes this is fine, but in practice, what you'll find is that it's impossible to really separate your units in this style of testing. And any time the order of your code changes, even if the actual effect of your code doesn't, you have to rewrite the test. Right? So if you put 1 and then put 2, but then tomorrow you want to put 2 and then put 1, the effect is the same, but you have to update the test. So that is a fundamentally flawed test to me, because you're not actually testing the ins and outs of your function. You're actually just testing that the code is what it is. So that's not very helpful. So thankfully, there's 2 awesome tools for fixing this problem. And if you're interested in trying to test Redux Saga, I strongly recommend that you choose one of them. One is Redux Saga Tester, and the other is Redux Saga Test Plan. So this is using Redux Saga Test Plan. And using one of these tools, you're actually able to isolate the ins and outs of your Saga function. So what are the ins and what are the outs? Well, the ins are clear. Effects, actions, should I say? Actions and state. And what are the outs? Actions and state. Right? That's it. So I'm able to expect that basically expect Saga returns a promise here when you run it. So this is just mounting up my Saga function for the test harness, and then I'm going to throw some actions into it. So I'm going to tick twice and make sure that I got some monster damage here, right? So if my hero took some additional time, some additional ticks to complete the damage, then I could just add more dispatches here. So I'm going to dispatch twice, and I expect that it will put out of my Saga the monster damage action. So for the interrupts attack, because I'm checking the hero's health, I want to actually load in. I want my Saga to work with a reducer. So you can either mock your Saga with fixed state or live state, that is, give it a reducer function. And so that's what with reducer here is. So I'm basically giving it state, I'm dispatching the tick, and I'm telling it that it got some damage, and I'm making sure that the monster damage was not output. So you can do the inverse assertions as well. So for watching the hero damage, again, it has state, we're dispatching, making sure that it, the health is 2, so, and he only took 1 damage, so he shouldn't be dead yet. But if the health is 1, which is default state, then we expect that our hero is dead. Now this is really getting fun here. So at math.random, well, I want to control randomness in my Saga test. And you can do that if you use that call helper function, right? So with the help of that call, it's not actually invoking that function, right? Behind the scenes, it's returning what's called an effect, which describes for the Saga runtime how you want it to invoke your function, right? But we're in a testing environment here, so execution is optional. So with the help of this provide function here, I can say, well, when you see call for math.random, here's the result. So I can say, all right, on a roll of 0.1, it shouldn't output damage, but on a roll of 0.6, then it should. All right. So here's the same sort of thing as the health above for the hero. And then the game. So you can go really crazy with Redux Saga test plan. So I actually found a bug here in the Redux Saga tester test plan trying to set this up. It was dispatching too quickly for my sagas. So you can actually throttle that with Redux Saga test plan, and you can control the timing for when those actions actually get dispatched. So here I'm delaying 10 milliseconds before each game tick. So I have to slow it down a little bit, which is why the tests take a little bit of time to run. They're not as fast as possible. So that's it. That's the entirety of the story when it comes to Redux Saga, and I hope everybody enjoyed the game. So thank you very much. If you want to try Redux Saga, here's a link to the complete game that I put together, and I really encourage you to add some features here, right? So I said that our player or our hero is a mage. You know, why not give them some mana? You know, you could use a channel to model this like inventory of mana, and you better be pulling some mana out of that channel at, you know, or have some mana to pull out of the channel in order to make the attack. And you could have regeneration there on the mana. I mean, you could truly model an entire game with Redux Saga. So I really hope you'll give it a try. Thank you. Any questions? No? No questions? We can talk about RPGs as well. I mean, that's fine too. All right. Well, thank you very much.
Okay, so thanks Adam for this great talk. Also thanks to Glenn again for coming all the way to Munich.